Yeah, good morning. Let us we discuss about the microcomputer. So this is very important before understanding any derivative 5 or 51 or any other microprocessor. First, we should understand what is microcomputer. So already you know what is computer. Any device it is going to do the computation. It is called the computer. Here we are going to call as a microcomputer. Micro is nothing but the size of the computer, not for the its computation capacity. The size of the computer is small. That is the reason we are going to call as a microcomputer. Microcomputer. So micro is nothing but a size. This micro meaning is the small size. Small size. Small size. Small size. Okay. So computer is nothing but computing. The small size computer, that is called the microcomputer. So this microcomputer consists of the main processor. It is called the CPU, Central Processing Unit, or we are also going to be called as a microprocessor or processor. Same meaning. We are going to call as a microprocessor or processor or processor or processor. Okay, same meaning. Processor or processor we are going to call. Say CPU, Central Processing Unit, or microprocessor or processor. So here we are going to call as a microprocessor. So it consists of arithmetic logic unit, control unit, register array. The arithmetic logic unit function is to perform the arithmetic and logical operations. What are the arithmetic operations? Addition, subtraction, multiplication comes under arithmetic operation. Logical operations like comparison, is it A is greater than B or less than B? There is a comparison. Logical operations. These are all going to perform by ALU. Then we have control unit. Control unit is one is going to distinguish the operation. Like suppose you want to read the data from a memory, the read signal will be sent by the control unit. So at a time, one device will be enabled. That will be taken care by the control unit. Next, register array. Register array consists of the registers. So more than one register, we are going to call as a register A. For example, register A, register B, register B. These registers are going to store the data. These registers are going to store the data temporarily. While executing a program, we are going to store the data in these registers. So advantage of storing the data in register is the speed of execution will be more instead of storing the data in memory. Then this is the main microprocessor. Then this microprocessor is not enough to perform an operation. We need other external devices also. Like if you want to give any data, we have to use the input device. The input device may be keypad, it may be keypad, or it may be a switch, or it may be a switch, or it may be a switch. So through that we are going to give the input. And output device, it may be LED, these are the output device, it may be LED or LCD, liquid crystal display, or 7-segment display, or the monitor, we have like computer monitor. Usually in a control operations, we are not going to use big monitor. Usually we have LED or LCD or 7-segment display. Okay, these are the output devices. Then our program will be executed by a microprocessor, but it has to be stored in some memory. So memory is the storage for the program and the data. The memory is of two types here. There is a main memory, there is a ROM. There is a main memory, ROM and RAM. Here we are going to talk about most of the time main memory, not much about the secondary memory. So we have ROM and ROM. In ROM, you are going to store the program. In ROM, you are going to store the program. In RAM, you are going to store the data. In RAM, you are going to store the data. So this is also called the code memory or program memory. And this RAM memory, we are going to call as a data memory. So ROM is a permanent. Once we store the information, it will be remain as it is, even though power is off. So, but in RAM, the data will be remain until power is available. If power goes, then content of RAM will be get erased. So your program will be stored in the ROM memory, data is stored in the RAM memory. The processor is going to read your program one by one instruction. As you know, the program consists of set of instructions. They are arranged in a specific order to perform a desired task. So here, the processor is going to read the instruction one by one and then execute. That is called fetch, decode, execute. Fetch, decode, execute means first you read the instruction from the memory, and to know the type of instruction, that is called decode. Then execute is nothing but perform the operation.